and then I'll have the entire file, right? So that's the entire file size. All I need to do now is load it. So I can go ahead and, I should probably also do this, right? So what I can do is just say, all right, I want to return this big, like, sort of chunk of memory that's just going to be the thing. So now I know the file size. I can just say, all right, the result, right, equals a malloc of that file size. So now I've got it. And then when I fread in, I'm going to fread in something of, well, actually, fread takes the buffer first, just because it does. I'm going to fread in that file size, and that'll be the end of it, right? So that's what I need to do to read the entire file into memory. And let's just go ahead and check to see how that goes. Let's make sure that that actually makes some sense, right? So OK, first thing I'm going to do is add it to our build.bat. So here we go. We already have a thing here where we compile our test asset builder, right? And so what I'd like to do there is just go ahead and compile this, right? So rem, this is our simple preprocessor, just our example here. And so what I'm going to do is just go ahead and compile simple preprocessor.cpp, okay? And now that will just, in theory, compile that for me. And it looks like it did just fine. And so now what I'm going to do is I'm going to actually step into it in the debugger and verify that it actually worked at all or did anything that I wanted it to do, right? Which would be a nice change. OK, so I'm going to open this up. I'm going to set it to operate in that directory where our code is, right, in Handmade code, so it can find the code, which, of course, it can find that file that I want to parse. I'm going to go ahead and step into it here. Here we are. I'm going to step in to read it, entire file into memory and null terminate. You can see me opening the file. It got the file just fine, which is nice. Let's see what it thinks the file size is. The file size is 3313. That's 3316. That's a totally reasonable number of bytes for that file. We're going to fseek back to the beginning, right? And then we're going to malloc something of that size and fread into it. And let's see if what we got was the contents of the file. There it is, right? That's the file. Sure enough, right? And you can see at the end here, it just kind of becomes garbage. The reason for that, of course, is that we have not actually done the null termination part, but that's pretty straightforward. OK, so that loads the entire file into memory. Again, really, really simple. So all I want to do now is I want to go ahead and allocate a little bit more space, right? Just one more byte for that null terminator. And then after we do the read in, I'm just going to say at the very end of the file, put that null terminator in. So now I've got a null terminated file, right? I got null terminated, the contents of the file null terminated. And so now what I want to do is I want to parse this thing, right? I want to go through it and I want to find whatever it is in there that I want to pull out. Now there's a problem with this. And the problem with this is that it could get pretty nasty in here. There could be lots of stuff. And I may not want it to pay attention to all these things, right? I may not want it to actually pay attention to something like move spec or entity type or whatever, or hit point. I may not want it to parse these structs. I may not want it to do anything with these. And so I need some way of annotating, right, what these guys are. And so what I'm going to do is I'm going to go into handmade.h, right? And up here in handmade.h, when we're talking, actually, I could even put it in handmade platform. Well, yeah, I'll just put it here. At the top of handmade.h, before anything else happens, I'm going to define a little bit of markup. And what I do typically for this sort of thing is I just define some macros that compile away, right? So what I'll do is I'll define something such as, introspection, right? Something like this. I don't know, and params, I don't know, something like this, right? I'll just, something. And the key part here is that it doesn't expand to anything. It's a macro that just literally vanishes, right? And so then you can do something like, okay, this struct right here, I want this struct to be like an introspected struct, right? And maybe that's introspection is probably done, maybe just introspect, right? And I just say like, oh, the category for introspection is brown butter, right? That's, I don't know why brown butter, because, it's tastier than regular, but I actually like regular butter. So, you know what, let's just say regular butter for now. Because, it's tasty, right? And I just say like, oh, the category for introspection, is brown butter, right? I don't know why brown butter, because, it's tastier than regular, but I actually like regular butter. So, you know what, let's just say regular butter for now. Regular butter is pretty tasty. Is brown butter, right? I don't know why brown butter, because, it's tastier than regular, but I actually like regular butter. So, you know what, let's just say regular butter for now. Regular butter is pretty tasty. Regular, but I don't know why brown butter, because, it's tastier than regular, but I actually like regular butter. So, you know what, let's just say regular butter for now. Regular butter is pretty tasty. Like, you get a baguette and regular butter, it's pretty good. If the butter's good and the baguette is both good, like, I can just say, I can see where the French are coming from on that, right? I'm American, but still, it's like, I was never one of those people who called it freedom fries, I guess is my point. So anyway, if I go ahead and compile Handmade Hero now, you'll notice this doesn't do anything, it doesn't create a problem for us. It basically just allows us to inject code that's only for our preprocessor, and that's crucial. It's crucial to compile Handmade Hero now, fries, I guess is my point. But like, I can just say, I'm pretty good if regular butter than Inspection is probably done, maybe just introspect. Introspected brown, the category for introspection, is brown butter, right? I don't know why brown butter, because, it's tastier than regular, but I actually like regular butter. So, you know what, let's just say regular butter for now. Regular butter is pretty tasty. Butter. So, you know what, let's just say regular butter for now. Regular butter is pretty tasty. Like, you get a baguette and regular butter, it's pretty good. If the butter's good and the baguette is both good, like, I can just say, I can see where the French are coming from on that, right? I'm American, but still, it's like, I was never one of those people who called it freedom fries, I guess is my point. So anyway, if I go ahead and compile Handmade Hero now, you'll notice this doesn't do anything, it doesn't create a problem for us. It basically just allows us to inject code that's only for our preprocessor, and that's crucial. It's crucial to understand how important that is. That's the thing you definitely need to know in order to start marking up that code. So we've got that in there now, we've got the file contents, and what we're going to do now is we're going to start parsing the file. Now, in order to start parsing the file, what you want to do is you want to build a relatively traditional parser structure, and the way that works is two phases, essentially. The first part of looking at the file involves what's called lexing. It means breaking up the stream. Instead of just being a bunch of individual characters, you try to agglomerate those characters into pieces that mean something a little bit more. And so, for example, you might think about the tokens in this right here as being things like the lexicographical tokens. I should have said they're called tokens. That lexing process is about binding the letters INTROSPECT into an identifier token. Like this is, or like a set of words, right? Then I've got a parentheses token, right? You might involve what you want to do code. So that's the thing. This doesn't do. I get that's I don't know. Is introspection, and I just say introspect, right? And I just say like, oh, the category for introspection, is brown butter, right? I don't know why brown butter. And I just say, that's introspection is probably done. Maybe just introspect, right? And I just say like, oh, just introspect, right? And I just say like, oh, the category for introspection, is brown butter, right? I don't know why brown butter, because it's and I just say like, oh, the category for introspection, is brown butter, right? I don't know why brown butter, because, you know, it's tastier than regular, but I actually like regular butter. So, you know what, let's just say regular butter for now. Regular butter is pretty tasty. Like you get a baguette and regular butter, it's pretty good. If the butter's good and the baguette is both good, like I can just say, I can think of, we want to do something that lecturers typically do. We want to eat up any white space, because typically, and it just is going to return this. Yeah, all right, brain, getting a little brained, it's true. That's right, we don't know that yet. That's not what I want to do at all. We want a way to determine, yeah, all right, brain, getting a little brained. We want a way to determine, yeah, all right, that's not what we don't know that yet. That's right, we don't have identifier. Oh, that's right. We don't know that yet. That's not what I want to do at all. We want a way to determine, yeah, all right, brain, getting a little brained, it's true. In order to figure out if something's an identifier, that's going to be a bit of a catch-all, because that's like anything could really be an identifier. So really what we want to do is focus on these guys first, right? If we see an open paren, we pretty much know what we're dealing with here, right? Our token dot type identifier. Brain. That's that's right. We don't know that yet. That's not what I want to do at all. We want a way to determine, yeah, all right, brain, getting a little brained, it's true. In order to figure out if something's an identifier, that's going to be a bit of a catch-all, because that's like anything could really be an identifier. So really what we want to do is focus on these guys first, right? If we see an open paren, we pretty much know what we're dealing with here, right? Our token dot type equals an open paren, and we're done, right? So I think basically, you know, these guys should be really, really straightforward. In fact, I could probably compress this down to something really straightforward, something that looks like this, right? And so here's the other ones we've got here. We've got closed paren, that's going to be this guy. We've got semicolon, that's going to be this dude right here, right? We've got asterisk, right? And there's a so all right. Let's go ahead to the Q&A. So on that's coming. So all right. Let's go ahead to the Q&A. If you could please, if you want to ask a question, please put Q: in front of it, and I'd be happy to go over everything. I know, like I said, we kind of wanted to do something weird, so I picked that one because people always ask me about how to do it on the stream. So now you know, and like you saw, it's real easy. You know, you can make a much better one than what I've done if you spend more than 60 minutes and aren't talking the whole time. But you get the idea. Q:. I see no Q:. Somebody post a Q: for me to answer. If there is one. If not, we can all just chill out. Paul Smith, it seems like you are doing recursive descent parsing. Paul Smith, it seems like you are doing recursive descent parsing. Is that how you would describe it? Yes, absolutely. I probably should mention that. So basically, there's a number of ways you can write parsers. And you know, since there aren't, I don't see a lot of Q: here, I'll just, you know, I'll start with like just a little bit of explanation here. Oops, how do I get my little interface back here? Where's the where did the little interface go? Oh, there it is. Okay. So here we are, day 206. And I'll just mention briefly. So for parsing, yeah, what I wrote is definitely considered a recursive descent. How do I get my little interface back here? Where's the me to answer? If there is one. If not, we can all just chill out. Paul Smith, it seems like you are doing recursive descent parsing. Is that how you would describe it? Yes, absolutely. I probably should mention that. So basically, there's a number of ways you can write parsers, and you know, since there aren't, I don't see a lot of Q colons here. I'll just, you know, I'll start with like just a little bit of explanation here. Oops, how do I get my little interface back here? Where's the where did the little interface go? Oh, there it is. Okay. So here we are, day 206, and I'll just mention briefly. So for parsing, yeah, what I wrote is definitely considered a recursive descent parser, and you know, to be fair, actually what I wrote is just a descent parser. We didn't actually use the recursion yet. Now we would if we had done, you know, if we were spending 2 hours on it and getting a little more of the type parsing in there, we would have. But what you saw me do is just to get it going a little faster, I used a lot of these while parsing blocks. So technically the way this works, you wouldn't do it this way. The reason it's called a recursive descent parser, the recursive part, is because normally what you do is you look at what you got. If you got an asterisk, you then call parse member again on whatever comes next, and you build like a tree that way. So I just did it, I did it kind of in a more fast and loose way. But like, you know, if Monday we go back, if people want to see me expand it a little, if Monday we go back, you would see a little more of the recursion that you didn't see because I was just kind of shorthanding it. So I made things in loops that really traditionally in a traditional recursive descent parser. Sorry, I didn't pack enough water for this stream, so my voice is going. Yeah, it can just be a smooth jazz stream from now on. So yeah, so if you take a look at that that asterisk thing, that would have been a case where recursion would have happened, the traditional recursion, and that's how that would have worked, right? And I could even show you kind of more like what that would look like. You know, you could imagine. In fact, you know, you could just imagine doing this. If you took out the while parsing thing, so you know, I'll give you the more sort of complete example, right? So assuming that we did it the more recursive way, so you know, I'll just imagine doing more like what that, and that's how that would have worked, right? And I can traditional recursion. And that's how that would have worked, right? Recursion. So yeah, so it can just be a smooth jazz stream from now on. So yeah, so if you take a look at that asterisk thing, that would have been a case where recursion would have happened, the traditional recursion, and that's how that would have worked, right? And I could even show you kind of more like what that would look like. You know, you could imagine. In fact, you know, you could just imagine doing this. If you took out the while parsing thing, so you know, I'll give you the more sort of complete example, right? So assuming that we did it the more recursive way, what we would do is something more like this, where we say, okay, just get the token. Whatever the token type is, we'll handle it. If it's an asterisk, I just want to do parse member again. Right? Something like this. And so that's exactly the same thing, right? But it's a little, like, you know, it's a little cleaner, it's a little nicer potentially. And so if I wasn't kind of being a little more compressed there, if this was a regular Handmade series where we're like, let's spend this week on metaprogramming, I probably would have thought it through a little more and and had something a little bit more that way, right? So yeah, if you take a look at how this works, I don't need to do that. And that's there, right? So that's like a recursive sort of thing where you kind of go down like that. And so now if we run it, you see we get the same output, but you know, I was just kind of, like I said, I was playing it pretty fast and loose. So this is a little bit nicer, and you know what, that's probably the one I would leave in there as well, so you know, that's just better. That's where the recursive part of recursive descent comes in. So just wanted to clear that up. Okay. So recursive descent parser, that's where the recursive part is that you assume that instead of like doing while loops to parse things that can have multiple components, you use recursion and the stack to do it. Descent is because we're going down the stack and up, right? So you can see that we start at like the outermost shell and we look at what the tokens are there. And when we get a token, we say, okay, descend one level down the stack and look at it a little bit more carefully. Decide what you want to do with it there. Look at it again, go a little more carefully, right? We descend down, so you kind of like, you're winnowing down the options as you go until you finally decide what it is you actually parsed, right? So that's a very traditional type of handwritten parser, right? So typically if you're writing a parser by hand like we just did, you write it this way. They're very nice because they're very flexible. You can do anything you want with them. You can put in ad hoc code to do anything you need to do. They're very understandable. It was probably, I'm guessing, pretty easy, even though I went very fast with that, for you to understand what was happening. You didn't just see like a big bunch of gobbledygook where it's like what's happening. But there are other types of parsers, right? There's like shift-reduce parsers and things like this. And oftentimes these other kinds of parsers, they use like rolling arrays and stacks and things, and they have jump tables that are made and all that stuff. And what they are typically for is they're for generation. So typically what happens is if you write a parser generator, so like Yak or Bison, if you've ever heard of these tools, they will spit out sometimes other types of parsers, which are they look like sort of machine table driven kinds of things. They're not really so much for writing by hand, although you could. They're just not as human natural. It's not what you'd first write, you know. And so yes, what we did on this stream was a recursive descent parser. It's a parser that's very traditional in that way, very traditional hand-drawn, top-down recursive descent parser, one token look ahead kind of thing. Very, very straightforward. Pseudonym 73, can you please satisfy my C standard anal retention? Pseudonym 73, can you please satisfy my C standard anal retention by accepting /v and /f as whitespace? Because I like pseudonym 73 quite a bit, I am more than happy to honor that request for you. That is no problem. Although, to be honest, I don't know, is there anything in particular I have to do? Like, there's nobody, all end of lines on all three platforms are /n or /r, right? Does C ever let you end a line with anything like that? You have to tell me, I've never used one of those, so. Gary Johansson asks, have you an opinion on OpenCLC? I've never really used OpenCL, and I definitely don't know what OpenCLC is, but yeah. So I'm sorry, I don't know what OpenCLC is. How would you handle errors if you were deep in the recursion? How would you handle errors if you were deep in the recursion? Is checking return values everywhere the best way? So error handling, usually what you do, it depends on the circumstance, but usually the reason why error handling is so bad in compilers is because it is a bit tricky. And so usually what I do is when I encounter an error, I typically do something like I try to put enough logic into the parser for my needs, but you can go more nuts with it. And usually what I do is I have an error token too, you know, so you'd have like token error that people can like pass up the chain. And I also have a tokenizer on the tokenizer. You call error and put errors into the tokenizer that it like stacks up. That's usually the sort of thing I do. I showed up late. Can you explain what introspection is? Sure. So actually, technically, there's different words. There's introspection and there's reflection, and there's different levels at which. Sure. So I showed up late. Can you explain what introspection is? Sure. So actually, technically, there's different words. There's introspection and there's reflection, and there's different levels at which these things happen. But basically, what we're talking about is in most programming languages, you typically have, well, obviously, a programming language is all about specifying structure of some kind, right? You are expressing the structure of data, you're expressing the structure of code, you're expressing all of these sort of structures, right? And these could be literal structures, like in C, it's a struct, it's literally just a collection of data. It could be a function, right? A series of things to execute with loops and whatever. And the compiler for your language knows what these things are. It has to, because it has to then turn that into working code, right? And so the key thing to understand is that structure actually has a semantic form somewhere inside the compiler while it's compiling the code. Now, languages that have a clue, languages that were made by people who know what they're doing, that's not even true. Languages that just, any language should have this, but C++ doesn't because it's just not maintained by people who know what they're doing. So C++ lacks a very crucial feature that most modern languages have. And that feature is the ability to look at those structures from within the code, right? So the structures that the compiler knows about inherently, you can get them during the compilation phase and do things with them that allow you to work with your code in very powerful ways. So for example, here is our entity structure that we were playing around with on Handmade Hero, right? It has these fields in it. I would like to print them out. There is no way in C or C++ to say, tell me all the members of the sim entity structure so that I can print them out. You can do it in other languages. You can do it in JavaScript even, you know. You can do it in all these languages. C++ can't do it. And that basic capability is called introspection. It's also sometimes called reflection, which is if you have the ability, I think, to like work to actually do more complicated operations than that. It's sort of it's a thing that it's a more stringent requirement, I think, on top of it. But point being, whatever you call it, what we're talking about here on the stream is the ability to do that. C++ doesn't have it. So what I showed on tonight's stream is how to implement it, right? How to put it back in there, because the C++ community is obviously never going to get around to it. So you need to, right? And so that's what we wrote. This is just a very simple little preprocessor that we can run on our code. And you know, here is that struct, right? That sim entity struct. And you can see when I go ahead and run this, right? In fact, I'll bring it up on here. Here's my sim region code. And here's, we ran our preprocessor. And you can see it printed out the members, right? Old chunk, storage, index, right? That sort of stuff. And we've got some bugs here, like this guy, right? You can kind of see even what happened. Oh, you know what? I introduced a bug, actually. You can see that we did it correctly before, but when I did that code just now for the recursive descent, spoke a little too soon. So if you look at that code for the recursive descent, there is sort of a nasty problem with it, which is if you look at these two guys, this one handled the semicolon end of stream thing. It would properly eat till the semicolon, but a recursive descent thing didn't. So really, until we do that, I guess I can't quite switch to that. And I'll put in, I didn't mean to undo pseudonym 73's thing here. Yeah, so it would not have worked properly the way that we were doing it before. Oops, I'm in the wrong place. There we go. Okay. So yeah, our original one worked better. I knew I must have had a reason for doing that way, but anyway. So you can see that we printed them out here. We got old chunk storage index updatable, type, flags, P, DP, distance limit, collision, facing direction, T-bob, D-abs tile, hit point, max hit point, sword, walkable dim, and walkable height, right? And so basically what we did there is add that introspection back in. So now inside our preprocessor, we can do whatever we want with those things, right? And that's exactly what we needed and what C++ doesn't give us. Let's see. Well, it just says, do you if John does metaprogramming for his language? I assume you mean, do you know if John does metaprogramming for his language? Do you mean, does it have metaprogramming? The answer is yes. He showed actually for the first time the metaprogramming features like Wednesday night. Just this past Wednesday, he showed for the first time some metaprogramming features he's added. So I think it probably will be pretty good language for metaprogramming based on how it's going so far. Certainly much better than C++, which doesn't support metaprogramming at all. Insofar as regarding errors again, would this be a place where exceptions would actually be useful? No, exceptions are never useful. I've literally never found a single programming problem where exceptions are better than not exceptions. For metaprogramming based on how it's going so far. Certainly much better than C++, which doesn't support metaprogramming at all. Insofar as regarding errors again, would this be a place where exceptions would actually be useful? No, exceptions are never useful. I've literally never found a single programming problem where exceptions are better than not exceptions. You know, your mileage may vary. If you like them, you like them. But I literally cannot tell you a single time when I've ever thought that exceptions were the right way to program something in my whole life. There was a time when I thought that exceptions were a good idea because that's what I've been told. But if I look back at all the programming that I've ever done with my current brain, I literally can't think of a single time I would ever say to use them. They are never good. I literally don't know of a single time I would use them. Evrare, now that we have the preprocessor, do you plan to make more use of it going forward in Handmade Hero? I don't know. I mean, we'll at least output the debug. We'll output the annotation, right? It'll only take us a day to switch that to a full annotator, so we might as well. We've got it, right? Hogan Long, who is John and what language are you talking about? I'm talking about Jonathan Blow. Do you plan to make more use of it going forward in Handmade Hero? I don't know. I mean, we'll at least output the debug. We'll output the annotation, right? It'll only take us a day to switch that to a full annotator, so we might as well. We've got it, right? Hogan Long, who is John and what language are you talking about? I'm talking about Jonathan Blow, the designer of Braid and The Witness, and the lead programmer on both of those products as well. He's writing a new programming language called JAI, which is actually pretty far along and it's quite nice. You can take a look at his YouTube channel, Jonathan Blow. Just search for Jonathan Blow YouTube, and you can find out about that. See, Voucher, I'm writing a parse that looks pretty similar to this, but it runs on multi-gigabyte files, which takes a while. Any common approaches to use SIMD multithreading to speed up text parsing? Seems more difficult since the characters aren't independent in the way pixels are. You know, there's a lot of ways to speed up parsing, certainly. I suspect that probably you could do some interesting things there, but honestly, I have never done parsing for bigger than just my code base, and even like just this method of doing it is always like many orders of magnitude faster than the compiler actually compiles it. So I've never had to optimize one of these, ever. They're always the fastest part of the pipeline for me, because like Microsoft C compiler is so slow that pretty much nothing I ever do becomes a compilation bottleneck. So if you're talking about, like you said, multi-gigabyte files, I do appreciate the fact that that would necessitate some serious thought there, but I just don't know. I just don't have the experience with it to know like what, you know. I guess what I'm saying is, in my head, I can sort of think of things like, okay, how would I start to approach it, right? But they're just fully speculative, and I just don't know. I would have to actually go tackle that program probably myself to have it really any opinion, because it's just not something I ever had to think about. To Sophos, this stream makes me feel like an extremely inferior and incompetent programmer. Do you approve of this? Not really. I mean, I guess I would just have to ask the question, like, you know, hopefully, you know, if you look at what I did there, it's not that complicated, right? Like, there's not that many moving parts to it. It's very simple. It's just something that takes a look at characters in a stream and makes some simple decisions about it, right? And so, you know, if you look at that and go, wow, he like did that really fast or something, you know, I've been programming for oh my God, 32 years. I've been programming for 32 years. I've written, you know, 5, 6 parsers, 7 parsers, something like this. So one of the reasons that was so fast is because I just already know basically how it works, right? And so it's just very like second nature for me to type that out. And so, you know, I would kind of discount that part of it. So what I would focus on is like, say, can you understand what I did? If you just spend some time, look at it, and practice a little bit. And if the answer is yes, then you're as good a programmer as I am. The only difference is you haven't written 6 of these, right? And a lot of times that's a big part of the difference, right? The reason that somebody looks like a good programmer when they're programming is because they just have a lot of experience. You know, the first couple times I tried to parse stuff, it was a disaster. I didn't even know about tokenizing. I'd never read a book on parsing. And it was like, they're awful. They were like always scanned for things. And I remember the first time someone like told me, you should like do a lexer. You should have a thing that breaks my tokens. It's like this huge eye opener for me, right? So I feel like, yeah, like don't get discouraged when you see someone who's been programming forever, like who's an ancient, like old, crotchety, cane, and I'm not even making that up. Like I am on crutches right now. Like here are my crutches. I crutched over to this to do this dev stream, and I will crutch out to the other room when I'm done. When you see someone who's been programming so long that they're on crutches at this point, and they're old and invalid, don't look at that and go like, oh, I can't program that well. It's like, well, duh. But that doesn't mean you won't 30 years from now, right? It's just a question of programming every day and like actually doing the practice. You just get better, and eventually you can program quickly. How does metaprogramming change your workflow? Can you talk about incorporating generated code with the regular C files? Yeah, so the way that it typically works is exactly what you just saw. Basically what we do is we'll take this and we'll have it start to output some things that are meant to be read as standing C structures. So for example, what I would probably do, right, is instead of outputting this debug value thing, what I would instead output is something like, you know, here is the name, you know, the field of the thing or whatever as a string, right? And I'd wrap that in something like this, right? And so this is more what we'd start to do. And now you can sort of see like, okay, this starts to be something we could just insert in a C file, right? And so then maybe we're like, okay, well now, you know, we want to insert this in a C file. We've got this parse struct thing. We get the name token out. All right, so now it just becomes like, let's go ahead and print out what the struct is, right? So we'll say something like char star members of, right? And then we just output that thing, like members of blah, brackets equals, and just going to go ahead and give you what the idea is here. Right? Ooh, excuse me. Right, and so you can start to see how this starts to become like actual C code. And so then you would just do something, you'd imagine you have like a member definition or something, right? And then up here, when we actually output this thing, we would also do like some kind of type field or something like this. So, you know, member type token would be here as well. So it would be something like, you know, type underscore percent dot star s, comma, member type token text length, member type token text. And it's not going to work quite right yet, but you can kind of see. So this starts to now, right, be kind of close to something we could just read in code and know exactly what our struct layout looked like, right? So basically what we do is we just take that, we output that to a C file, and then we compile that C file in with the rest of our C files. Now we have introspection data, the kind that the C++ spec should have been giving us for the past 2 decades and wasn't, right? So it's just about getting that in there in a way we can use. So, all right, so that's pretty much all the time I've got. I don't think I got any more time for questions. So I'm just going to go ahead and wrap up, because if you're watching the Dev Streamathon, then you are going to want. I'm just going to pretty much. All right, so that's pretty much all the time I've got. I don't think I got any more time for questions. So I'm just going to go ahead and wrap up, because if you're watching the Dev Streamathon, then you are going to want to. It's going to roll over here in 5 minutes to the Salt and Sanctuary, I believe, is the next dev on the stream. So I'm just going to go ahead and save this out and close down and say thank you for joining me to this special edition of Handmade Hero. It's been a pleasure coding with you as always. I hope that satisfied some people's desire to see how metaprogramming, how you sort of start to get that working. That is the basics of it. Like I said, you saw it can happen in an hour. And of course, now it's in the Handmade Hero codebase. So if you're somebody who wants to play around with it, handmadehero.org, you can always pre-order the game, and it comes with the full source code. So you can just download the source code and play around with it and see how that works if you are still a little confused about how the metaprogramming stuff works. And maybe we'll do some more of it on Handmade Hero in future streams as well, if people feel like they just want to see like a little bit more of how that sort of thing works. So that's about it. Until next time, oh yeah, if you want to catch this stream live again, please do remember also that we have a little tweet bot here. So if you want to see the schedule, you can see the schedule. So handmadehero.org, you can just go there and there's a little tweet bot. It'll tweet out the schedule at you, and you can see that it's just like, you know, every week it has a little thing here which will say like, here's what the stream times are going to be, and then every day it just tweets out a little thing that tells you what the time is that day, if you're wondering. So it's a pretty handy little guy. That's about it for me. If you're watching the Dev Streamathon, it's twitch.tv/devstreamathon. Like I said, it goes, I think, for 24 hours. I think it started a few hours ago. So it's going all night, and it'll go all day tomorrow as well. There's a bunch of devs on there doing stuff. So definitely check that out. If you're someone who just came for the Handmade Hero and hasn't had enough live coding for one evening, you've got more. So you can go ahead and switch over to that. And I guess I'll just keep talking until 10 p.m. Because I don't know when they'll actually switch over the stream. Hopefully at 10 p.m. exactly. So there we go. And I guess I'll take this opportunity also to say thank you to everyone for tuning in. As always, all the Handmade Hero guys, it's great to see you here every day. It makes it a lot less lonely to code knowing that there's so many people who come to visit. And I I hope you enjoyed that metaprogramming. It was the thing I'd been thinking all week about what I thought we should probably do, and I was like, well, we could do, people had mentioned maybe do some lighting stuff and maybe do some animation stuff, and I think those were all good ideas. But what I thought at the end of the day is I was like, well, Handmade Hero is what it is. It's a stream about actual, like, very serious programming, and it's about the programming. And so I felt like people who were watching the Dev Streamathon, I didn't want to do something that would give them the wrong idea about the sorts of things that we do here. Like, we do very low-level stuff. That's what we're about. We're not about, like, making a game. We're about learning to program a game, and those are two very different things, right? And so I thought that something like that would be a good example. It's a self-contained thing. I knew I could do it pretty quickly. I've written so many metaprogramming things in my life. I knew it was something that, we had a chance to get it done in an hour. As luck would have it, we did. That was not a foregone conclusion. And certainly it was right down to the wire. But as you saw, that's kind of the sort of thing that I feel like typifies Handmade Hero, is that kind of programming. And so I thought that would be a good example, and also something that people who watch Handmade Hero every day would also be entertained by, because I know that a lot of people have asked for that in the past, and that they would want to see that. So that's it. Thanks everyone for joining me, and hopefully everyone will stay tuned for some of those Dev Streamathon things. Let me know how that is. I'll probably go switch over and take a little bit of a look at it myself. So take it easy, everyone, and have fun coding. I'll see you guys back here on Monday.